Okay, position, displacement, and distance. It occurs to me the reason why I frequently say okay at the beginning is I'm checking to make sure it actually is recording. All right, we need to define position, displacement, and distance. Position is your location with respect to a reference point. That reference point can be anything, but it is usually the origin of your coordinate system. Displacement is a little bit more interesting. So for displacement, it is the difference between two position vectors. And it shows in what direction and how far you traveled between 2 points. So for displacement, both the magnitude and the direction matter. It is also a vector quantity. Distance, not a vector. It measures how far you have traveled, but doesn't care about direction. You can think of it as the number of steps you take without worrying about which way you are going. All right, we are going to talk about this in one dimension, and the easiest way to think about it is to use a number line. So we'll put our 0 point somewhere here, and we'll count out some number of steps in each direction, and then we'll come up with some locations that we can go between. So 1, 2, 3, 4, 5, 6, 7, 8. Imagine that these are uniformly spaced. And 9. Then on the other side we'll have -1, -2, -3, -4. I don't care if this comes out symmetric or not. So -6, -7. We'll throw not quite that far out. -8. All right, so relative to that 0 point, we're going to set some locations. So here in pink, we're going to put location A. Let's actually give it a better name. Home. So the pink, your home is at position 5. Then let's say you live fairly close to the supermarket where you shop. We'll put that over here at 7. Call it market. So here, market at 7. And then let's put school. School. Somewhat further away. Oopsies. And that'll be at position -6. So if we're trying to find the position of each of these, we would have to draw these position vectors that show you how to go from 0 to wherever each of these objects or locations are. Okay, so those would be position vectors. We're not actually going to really use the position vectors right at the moment because we're going to try a few different problems and we're going to look at what is the distance versus the displacement for a few different cases. So remember these definitions. Displacement is just the difference between two position vectors, and it will show in what direction and how far you have traveled. Distance is not a vector, it just cares about how many steps you take. So for the simple ones, we'll find that the results are exactly the same. As we get more complicated in what we're doing, we'll find a difference does emerge. So let's start with this. We'll start with displacements, actually. First, we're going to look at the displacement from home to the market. Then we're going to look at the displacement from home to school. After we've got that, what is the distance from home to market and the distance from home to school? So these are the ones that will come out pretty much as you expect. So here, if we look at the displacement vector, we've got one that's further away than the other. We'd take our further one, our final location at the market. We'd subtract our initial one at home. We would get a net vector that would point from home, oh, I need to change tools, from home to the market. You would find quite simply, I'm not liking that dark blue, it's a little too dark. The displacement vector, delta r, would look something like this. So displacement, I did forget to mention symbols. Displacements tend to be delta r. Distance, just something like d. Alright, so here we'd find delta r is 2 units to the right. Okay, then we can look at what happens with the school for the second part. We have to go the other way. We're going to have a -6 and then minus the 1 to get to your home, so -6 minus 5. Delta r in the second case would be, let's see, 5 and 6 is -11 units. Or 11 units to the left. Okay, notice I'm having to specify direction somehow. Technically, the first one you could just say it's 2 units because the plus implies it's to the right already. Distances. Alright, so we need to think about how many steps you take. So here you've got 1, 2 hops and you're at the market. The distance to the market is just 2 units. The distance from home to the school is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. Notice no minus sign, it's just a distance. Alright, where things get interesting is if you go somewhere and you turn around part way. So let's look at distance from home to market to school. Actually, I went displacement first. Displacement from home to market to school. And then we'll look at home to market to school. Alright, so for displacement, we are really only going to care about delta r, which is your r final minus your r initial. So in this case, our r final is -6 minus our r initial. Our initial location is at home, which is 5. So it's -11 units, or 11 units, I forgot the t, to the left. Distance is another issue. To actually follow this process, we're going to have to take hops to the market, 2 steps, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me check that. So that should be 11, 12, 13, 14. This should be 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So 15 units. Change the color. So they aren't the same size anymore. You can't just take the absolute value if you have a change in direction. What if it was all going the same way? Well, that actually still will work out the same. So as a quick example, what's the displacement from school to home to market versus distance from school to home to market? Okay, well, our final in this case is 7 for the distance, or sorry, for the displacement. So our final position is at 7. Our initial position is at -6, so it'll be 7 minus -6. It'll be 13 units, and of course that's to the right. What about the distance? Well, let's look at hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hops. So notice if there's no change in direction, the distance and the displacement are the same thing. If the motion has a change in direction, the distance and displacement are no longer the same. You do have a homework problem related directly to this idea. Parts A and B will be you're going the same direction the whole time. Distance and displacement are the same thing. C and D, not so much. You'll get different answers. What you'll have to think about is that turnaround, where you finished going one direction and turned around and came back the other. So check that out when you're doing your homework. You'll see this problem very definitely. All right. I think you get 13.5 for A, B, and C, and then 22.5 for D. You get a very different answer because of that change in direction. So the distance ends up being much further because you have to turn around and come back. All right, that's it for this one. I'll see you in the next video.